G'day, welcome to the first video of applications of integration, and to be honest, this is what we've been building towards. This is where all your anti-differentiation and all that sort of stuff, this is where we start using it, and this is the power of calculus. Differentiation is very, very powerful, but anti-differentiation and integration is perhaps even more powerful than that. So what we're talking about today, firstly, is area under a curve or a function, that sort of thing. Okay, so area under a curve, and basically, if you have some function y is f of x, get some function, then the area under the curve between 2 points A and B, in other words, this area all under here, that area is equal to the integral of f of x dx between A and B, and it's as easy as that. So if you're trying to figure out the area, all you need to do is take this integral between those two terminals A and B. Now, the important thing to understand is that this must be if the function is above the x-axis. Okay, so if you have the situation where your function is below the x-axis, so something like this, I should have drawn that a bit differently, and I will. If you've got this situation where it's below down here somewhere, so that's your f of x down there, then what you get is your integral will actually be negative, so between A and B, so that will give you a negative result if you do that. So if you're asked to find an area that's below the x-axis, then what you need to do is get the negative of this, because otherwise you'll get a negative result for the area, like that. Okay, so they're the two situations. If it's above the x-axis, just treat it as per normal. If it's below the x-axis, just be a bit careful, and you'll need to, if you don't put this negative in front, you'll get a negative answer for the area, which is a bit strange. So the other thing, the other cases that you get, if you get something like this, where the function, so it goes up, and I'll just put that in red, if it goes up like that, something like that, and you're asked to find the total of those areas, something like that. What's the total green shaded area there, where you've got your function fx there, and let's say that's point A, point B, and point C, then your area, in this case, your total area will be the integral from A to B of fx dx. In other words, you'd have to break it into pieces, because you've got that area there plus this area here. And if we add that area there, we're going to go plus, let's add that area. What is that area there? Well, it's negative the integral from B to C of fx dx. Okay, so you're just going to be careful there, so it's actually minus there. So be careful in those situations where it crosses from being above to below. You should remember that an integral below the x-axis will give you a negative value. And that's basically it, except for the fact where you've got some function, but let's say instead this function you are asked and you want to know between A and B. What about if you want to know this vertical area here? So far we've been talking about the area between the function and the x-axis. What about if we want to know the area between the function and the y-axis, between the points A and B? And the area in this case is exactly the same, where you've got from A to B on the y-axis, and in this case it'll be the function in terms of y dy. In other words, up here you had y is a function of x, and that's what f of x is. In this case you'll have x as a function of y. In other words, find the inverse of f of x and use that as your integral between A and B. And so that's basically it. That's the sort of the theory. I'm just going to crack into some examples. I might not get through all of them. I'm going to quickly go through them because they take some time. I don't want to teach anti-differentiation here. I just want to quickly talk about it. So if we've got y equals negative x squared, I'm going to choose some pretty simple functions. to do because they take too much time to do. So we've got this function. What does it look like? Roughly negative x squared plus 1, so it goes up something like that. And what we want to do, we want to find the area between that and the x-axis. So what's that area in there? Now the important thing to do is to find out where on the x-axis it actually crosses. So what are the 2 points that we're going to integrate between? So just look at a sketch of that. It actually crosses at -1 and 1. So so that's nice and easy. So our area in this case, our area will be equal to, now it's above the x-axis, so that's nice. It goes between -1 to 1, and we write our function here, negative x squared plus 1 dx. And that's equal to, we can integrate that straight away, we know how to integrate that. There it goes up to a 3, so it's negative 1/3 x cubed plus x to 1 to -1 equals, and then we just evaluate this. So put the 1 in, that'll be negative 1/3 plus 1 minus, put the negative 1 in, you'll get -1 there, it'll be a positive 1/3 and minus 1. This equals negative 1/3, negative 1/3, so that's negative 2/3. And you've got positive 1 here, positive 1 there, so that's plus 2, or 6/3, and so the answer is 4/3 squared. So that's the area underneath there, and it's as easy as that. I've chosen a very simple function because I don't want to spend ages integrating, but that's the idea. Let's look at another example. Let's have a look. How about if we have this function here? Let's look something like that, and what it is, it's y equals, what did I say, log e x plus 3. Okay, so looking at that, and we want to evaluate it between -1 and 1. In other words, we'd like to find out sort of that area there between 1 and -1. Find that area. So remember, just a little tip, if you're trying to find the area between a function and the x-axis, then what you want is the x points, if you like, the x points, and also you want a function of x. Y is a function of x. Okay, so that's if it's to the x-axis, right? If it's to the y-axis, then what you're trying to do is you want the y points. In other words, what are the points on the y-axis? And you want x as a function of y. So that's what we're looking for. So for this case, we want x to be a function of y. So what we need to do is rearrange this. So let's go and do that. So firstly, get rid of this log base e. How do we do that? We raise to the power e. So therefore, e to the power y equals x plus 3. Therefore, x equals e to the y minus 3. And that is our function of y. Okay, so there's our function of y. Great. Therefore, the area, supposed to go to green there, didn't work. Therefore, the area is equal to the integral between, what are your y points? -1 to 1. And our function of y is this here. So it's e to the y minus 3 dot dy. So it's dy. Remember, we're in terms of y. So that's equal to, let's integrate it. What's the integral of e to the y? It's just e to the y minus 3y. And between the points -1 to 1, and then we just evaluate it. I don't want to waste your time or anything like that. And you're going to see what I've done wrong, hopefully. So e to the 1 minus 3, so that's the first lot, minus, put -1, e to the -1 plus 3. And that equals e, we're going to get minus e to the -1, whatever that is, and minus 6. Okay. Now, if we have a look at this, if you put this into your calculator, what you get, e is 2.7, 1 over 2.7 is some small number, so it'll be 2.7 minus some small number, minus 6. You're going to get a negative answer here. You're going to get a negative answer for your area, so you found that the area is negative. Why has that happened? Well, it's because in the same situation, if you've got an area between the x-axis like that, you're going to get a negative answer. The same here, because we've gone into the negative y values here. here we've gone into negative x values. It's on the other side of the graph. It's not in positive x values. And so what we've got is negative result here. So what we should have done at the start is put a negative here because we're in the negative region on the graph. And that's why we've got this negative answer. So if you put that in your calculator, you'll find that's negative. Cool. I might leave that there for the video. I'll do 2 more tricky ones in the next video.